All right, so -6 divided by 2 times 1, so that'd be -6 divided by 2, so that's going to be x equals -3. So our axis of symmetry is x equals -3. We found that by using that formula. So you've got to have that committed to memory. The next thing is the vertex. We've already got half of it done. The x value is that -3 that we found up here. These things should always match. Axis of symmetry and the x value of your vertex should be the same every single time. So you're getting, the saying is 2 birds with 1 stone. Okay, so when you find that axis of symmetry, you're actually getting the x value of the vertex. You get something for free. Now, how do we find the y value that goes with that? Plug it in to the problem. I'm taking -3 and plug it into the problem. Here's the nice thing about your graphing calculator. We're going to set up our calculator to help us build these ordered pairs. So with your graphing calculator, get that out. Clear out all that stuff. There's a couple of different ways to do it, and I want to show you the most efficient way to do it that's going to help us later on when we build that table. And some of you may already know how to do this, some of you may not, and that's okay. I want to show you some tips and tricks and things that can help you along the way. So if we're going to graph something, we know we go to the y equals menu to do that, right? So let's go there first, because we're eventually going to graph this quadratic. So hit y equals. I've got some stuff in there that I'm going to clear out that I used last block. And we're going to type in that equation. X squared plus 6x plus 9. Okay? Just typing in the quadratic that's given to us. The next thing to do is we want to look at a table, or actually plug in the x value that we want. In order to do that, we need to set our calculators up to be able to type in the x values we want. To set your calculator to do that, you're going to hit second and then the window button. Second window, and then you want your independent. It doesn't matter what's here at table start and delta table. It doesn't matter what's there. You can have anything you want there. It just can't be blank. On the independent variable, you want to set that to ask. So you just press the arrow down. If yours looks like that, it's got auto darkened in on both of them, just press over to ask and hit enter. And then on the dependent, that's the y value, we want it to be automatic. Okay, it'll generate that for us out of that. Okay, so you want your independent set to ask, your dependent set to auto. If you do that, that's going to allow you to type in the x values that you want into the table. Okay, the next thing we want to do is from the y equals menu, you won't have to go do that every time anymore. So second window, make sure the independent is set to ask, the dependent is set to auto. Is everybody with me on that? I don't want to run off and leave anybody, because if yours is not set that way, you're going to have trouble. Okay. Okay. All right. All right, so we're going to type in the equation x squared plus 6x. Second window. And then now everything you're good to go. Anybody else need some help getting yours set the right way? Yeah. All good. Once you get it, look, if you got a neighbor next to you that's good at these calculator things, use them to help you. All right, now, everybody, we're there. The next thing we want to do is actually go to the table. So I'm going to hit second and then graph. And mine's already got some values that I typed in earlier from something else that I was doing. If yours has x values already typed in and y values, it doesn't matter. We're going to type over the top of them. Okay. So what we want to do is type in the x value that we want to work out. What's the x value from our axis of symmetry? -3. So we're going to type in -3. So you just type -3 and hit enter. And it cranks out the y value right beside it. So we get this ordered pair built for us. -3, 0. Here's that error. Let's see. Get y equals 1. Good there. Anybody else having trouble? Raise your hand. I'm coming around trying to be good. You don't have to that way. X squared plus 6x. That's what it is. Yours is still, it's doing that. Right. X squared plus 6x squared. 6x. Now, I mean, X squared. X squared plus 6x plus 9. Now it's second and second. Now we want to get to the table. Second and then now you're good. All right. Who else needs some assistance? I'm getting that -3, 0 on the top there. Here's where you want to all these others are already done in okay. Anybody else need some assistance? All right, that's going to help us later on. We start building up the table that we're going to use to draw the graph. All real and complex. If they're all. Okay. All right. So we have that as the vertex now. So we plugged that in. We found out that y was 0 when x was -3 out of that. So that gets us our vertex. What do we know about that vertex? Is it a maximum or a minimum? What's A? For this problem, what's A? What's A? 1. It's a positive one, right? So this one opens which direction? Up. So it goes like this. So it's at a lowest point. So it's a minimum. That vertex is a minimum. Okay, so we're finding the vertex and whether it's a maximum or minimum. Okay. So anytime if you're dealing with quadratic things and it talks about maximizing or minimizing, if it's a quadratic function, it's talking about profit or revenue or something like that. If it's talking about maximizing or minimizing, it's talking about the vertex. It's all we're talking about. Okay, so anytime you see the words maximizing or minimizing, you're talking about the peaks or the lowest points. That's what we're talking about here. So it's all dependent on what A is in the original problem. Standard form, we do vertex form, we do intercept form. A decides maximum or minimum every time. So you can really decide that before you even find the vertex. You don't have to find the ordered pair to decide if it's a maximum or minimum, just based on the A. Okay. So if A is positive, we got a minimum, and it's at this point, -3, 0. All right, the next thing that we would find would be the X-Intercepts. That's something that we just finished up doing, solving the quadratic. So the X-Intercepts, we're taking x squared plus 6x plus 9 and setting it equal to 0. Options for solving that. Factoring would be an option because it's trinomial. So we could try the X method for factoring. Is square roots an option for this one? Why not? Because it's got the plain X in it. If it's got this plain X in it, we can't do square roots. So we can either factor it or do quadratic formula to solve it. I'll do it both ways just to show you get the same answers no matter which way you do that. So if we factor it, do the X method, 9, add to be 6, that's 3 and 3. So our factors would be X plus 3 and X plus 3. Both of them are the same number. And you set those equal to 0. You get X equals -3. So the X-intercepts at -3, 0. Happens to be the same as our vertex. Doesn't always happen that way. Doesn't matter if it happens that way. Okay? That's a repeated 0 because it happens twice. You got the same factor twice. It's what's called a repeated 0 or repeated X-intercept. It just means it happens twice. Okay? All right. Now, the next thing that we would want to do is the Y-intercept. Let's go right here, do the Y-intercept. Because it's in standard form, the Y-intercept is easy to find. Where's it at in the equation? C, it's the 9. So our ordered pair for the Y-intercept would be 0, 9. Y-intercept in standard form is a give me. It should be that quick and that easy. You should not have to calculate anything if it's in standard form to get the Y-intercept. So there's our Y-intercept. Okay. The last thing that we want to do is build a table. And we're building a table. We're going to pick some X values and find the Y values. We've already got some. We did the vertex, right? The vertex was -3, 0. That was the ordered pair there. I just laid on top of those. Perfect. Thanks so much. All right, so -3, 0 is the vertex. I'm going to put the vertex in the middle of my table. The reason I want to do that is because I want to build the graph around it. I know that this is a parabola and it opens up like that. I want that vertex to be in the middle of it so I can get a good picture of both sides of the thing. I just need a couple of points on either side. So I'm going to pick 2 X values to the left of -3. So that'd be like -4, -5. And then 2 X values that are close to the same distance away from -3 that are on the right. So that'd be -2 and -1. Make it easy on yourself. Pick some nice ones. The good thing is, by using that graphing calculator and the table that we've set it up to where we can type in the X values you want, all you got to do is go to your calculator and go to second graph. And instead of typing in -3, we're going to type in -4, -5, -2, and -1. And we're getting these Y values that go with those so we can fill in our table. So we have -4, +1, -5, +4. So on my table, and then -2 was +1, and -1 was +4. What that creates is a nice graph of that parabola. That looks like a straight edge. So on the graph paper, this is what you would do. You draw yourself a coordinate plane. Doesn't have to be huge for this one. It's not a very, very large graph. The numbers are not real big. And I'm going to plot these points on the coordinate plane. -5, +4. 2, 3, 4, 5. 1, 2, 3, 4. -4, +1. -3, 0. -2, +1. -1, +4. That creates that parabola shape. Here's what the axis of symmetry looks like. It's this dotted line that runs up through the middle of that. That just shows me, hey, I could fold that. If I could pick this screen up and fold it, it would match up side to side on that. So whatever point across from any point here is going to be the same Y value out of that. It's a symmetric graph. If you hit on your calculator, if you hit graph without hitting second, you get the exact same picture. So you should be able to take a picture that you've drawn by hand, and if it doesn't look like that, you need to check two things. You need to check your equation to make sure you typed in the equation correctly. Do that first, because that's a very common, easy thing to fix. If you didn't type in the equation correctly, a lot of things are wrong. You should probably need to start over. Okay. If it doesn't match and you did type in the equation correctly, then you may have plotted them wrong on paper. You need to go back and X left to right, Y up and down, that sort of thing. Okay. So graphing out of standard form. Those are the things that you need to be able to do. Am I going to ask for all of those things on one problem? Probably not. I might ask you for just the intercepts, X and Y intercepts on a problem, and you just find those. I might ask you what's the axis of symmetry for this problem. So be able to find all of those things, but on a quiz or a test, I'm not going to ask you for everything on every single problem. So when you're working practice for this, the Khan Academy kind of breaks it up into pieces, like I'm going to ask questions out of that. So think about this in terms of pieces of it, not in, I've got to do every piece of this to get every problem right. No, be able to find individual parts and know what parts you need for that. Okay, so let's look at the next form, which is intercept form. That's the next form I want to talk about. Intercept form. Intercept form looks like this. You got A, that same A that was from standard form. It's not changed what it does or how it works. And then you have factors. Intercept form sometimes is called factored form. Intercept and factored form are the same things. And they have X minus M, X minus N, that sort of thing. The M and N are just numbers. They're the X-intercepts, actually. It's called intercept form because the X-intercepts are easy to find from this form because it's already factored for us. And we know from what we did with solving, if it's factored, we take each factor and set it equal to 0, and we get where it crosses the x-axis. We get the answer, the solution to that. Those are all the same things, okay? So let's look at an example and learn how to do this and get the same things that we found with standard form, but with intercept form. So I think we're going to still find axis of symmetry. We're still going to find vertex, maximum or minimum with that. We're still going to find our x-intercepts and our y-intercept, and we're also going to find that table. But we're going to do it from intercept form instead of standard form this time. So the same 5 things. The good news is a lot of the same things we did with standard form are right here with intercept form. It's not learning anything new. It's the same stuff, okay? So example B, negative parentheses, x plus 5, close parentheses, another set of parentheses, x minus 3, okay? Here we have an intercept form of a quadratic. We know it's quadratic because if you multiply it out, you get x squared is the biggest piece, okay? As we go a little further, starting next 9 weeks, we'll get polynomials going, and we'll get bigger x cubes, x to the 4th power, x to the 5th power, that sort of stuff. So quadratics are what we're dealing with now, though. So first thing is axis of symmetry. Just going to keep that the same order, even though some parts are easier than others. Okay, because it's axis of symmetry, the method that I'm going to tell you to do, and I'm going to mention another method as well, but the one that's probably the least problematic for most of you is to just multiply this thing out and multiply out negative and then x plus 5, x minus 3. If we multiply that out, x times x is x squared, x times negative 3 is negative 3x, 5 times x is 5x, 5 times -3 is -15. And then multiply that by -1 and simplify. So that's going to be -x squared minus 2x plus 15. We've taken that quadratic that was in intercept form and put it into standard form. Okay. What does that allow us to do now for axis of symmetry? Yeah, do that formula that we used before, -b divided by 2a. So multiplying out this lets you use that same formula. And that's the way most people do this. I'm going to tell you about something else that's somewhat of a shortcut, but sometimes it's a little complicated for folks and they don't like doing it that way. So this is the way most of us are going to do this. This is the way I do it a lot of times, is this way. So I take -b divided by 2a. So that'd be 2 over 2 times -1, which would be -1. So my axis of symmetry is x equals -1. The other method for finding the x value for the vertex or the axis of symmetry is to take the x-intercepts and get the midpoint of those. So what would be the solutions to this if we set it equal to 0? X would equal -5 and +3, right? If we said x plus 5 equals 0, we get -5. If we said x minus 3 equals 0, we get +3. What's halfway between -5 and +3? How do you find halfway between those two x values? If Jacob scores a 90 on the test and Eli scores an 80, what's halfway between that? How do you know? Okay. All right. Take a tougher one, 92 and 84. How can you find halfway between two numbers? Absolutely. You said add them together and divide by 2. That's how you find halfway. So -5 plus 3 would be -2. Divided by 2 is the same number we found by the -028. Okay? That's a little more, I don't know if it's a trickier way. To me, it makes a lot of sense to do it that way. But it's the relationship between the vertex of a quadratic and its x-intercepts. The vertex of a quadratic is always halfway between the x-intercepts. So if you can solve it for x, you get x-intercepts, and you know the vertex is going to be halfway between that. If we go back to example A, our x-intercept was -3. What was our vertex? The same number. Where's halfway between one number? It's the exact same number. It's coming. You can't go halfway between one number. It's on the same place. So you can add up the x-intercepts and divide by 2, and that'll get you the number for the axis of symmetry and the x value of the vertex. That's a possibility. Most of us will do it this way because it seems to be easier, especially if there's weird numbers in here. It's a little easier to do by multiplying it out. But that's another possibility for a way that you could work that. Again, I think most of us are going to do it this way because it seems to make more intuitive sense and you don't have to learn something new. But the other way also works. Okay, so next would be the vertex. So we already have half of that, -1. How do we find the other half? Not necessarily, we don't know for sure. Plug it into the problem there. So f of -1 would be -1 plus 5, -1 minus 3. So we're just working out that math. So that'd be 4 times -4. So that'd be -16 times -1, +16. So our vertex is at 116. No matter how you get the x value for the vertex, you're going to get the y value for the vertex the same way every time. You're going to plug that number in and work it out. unless it's in vertex form, and then there's a shortcut. Okay. Recognizing these forms is going to be important so that you know which shortcuts you're going to have. Is this going to be a maximum or a minimum? What's A? What's A? You're right there. It's -1, right? So it opens down. So that's going to be at the top. So it's going to be a maximum. All of it depends on A, guys. Because A is -1, it's this number in the front here. -1 is right there. That's A. That decides which way this thing opens. If it's negative, it opens down. You got a top on that. If it's positive, it opens up. So you got a bottom. That's a minimum. Okay. Vertex, -1, 16. It's a maximum for that. The X-intercepts, this is the short part of this particular problem. To find the X-intercepts, we take the problem, negative, and then x plus 5, x minus 3. Set it equal to 0. So we end up with this x plus 5 equal to 0 and x minus 3 equal to 0. -5 and 3. -5, 0. 3, 0. Get 2 X-intercepts on this one. Just going to help us when we go to graph it, because when we already got 2 points made on for our table. Okay. The next thing that we want to find after we find the X-intercept is the Y-intercept. Not quite as easy when it's in intercept form, but the good news is if we did the work to multiply it out to get the vertex or the axis of symmetry, it is easy. Look back at what we did for that first step. When we multiplied this out, we got standard form there. What's the Y-intercept when it's in standard form? C, 15. The good news is you get a few things for free in each form. Standard form, you get that Y-intercept really easy. So if you got it in standard form, then you've got the Y-intercept. If you've got it in intercept form, it's really easy to get the X-intercepts or factored form. Intercept form, factored form, same thing. X-intercepts are really easy. Okay, not quite as easy in standard form. Okay. And then the last thing that we're going to do before we draw the graph is a table. Here's the great thing about already having the X-intercepts, and there's 2 of them. They're not the same as the vertex. We get some stuff in our table for free. We know we're going to put the vertex in the middle. It's -1, 16. But we know that it's crossing at -5, 0, and 3, 0. Right? I'm just going to get an ordered pair that's between there. So I'm just going to go -2 and plug it in. And I'm gonna put 0 in and plug it. I already know 0, 15 works. Because that's my Y-intercept, right? What do you bet the Y value for -2 is 15? $5? I bet it is. Plug it in to find out. Negative. If I plug in -2 in here, -2 plus 5 is 3. -2 minus 3 is -5. So 3 times -5 is -15. Times this negative here makes it +15. Same number. Part of that symmetric idea of a quadratic, that it's got the same Y values on both sides out of that. So that helps us in graphing this. So when I go to draw my graph, I've got to have a little bit bigger of a graph here because it's going up to 16. So I might go by 2s on my graph paper or something. Or I think I've got room. I can draw the whole thing. Maybe here. If I draw a really tall one. And go to -1, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's 0, 15, -2, 15, -5, 0, 1, 2, 3, 4, 5, and 3, 0. my axis of symmetry drops right down through the middle. And then I'm going to draw the parabola. Not great at drawing these, but I'm better than I used to be. There we have a parabola. It's a little skinnier than the first one we drew, but we should be able to see this thing happening on the calculator. So if I go to the calculator and I put in that equation, negative parentheses x plus 5, close the parentheses, another set of parentheses, x minus 3, and I hit graph. I can't quite see everything, but I do see it looking similar to what I drew because it's crossing at -5, 0 and +3, 0. If I zoom out, and the way you can do that is hit zoom, and then the number 3 says zoom out, and just hit enter, and it'll zoom out. That looks kind of similar to where I'm at. It's like the graph I drew. It opens down, fairly skinny. Now, if you want to go back to the 10 by 10 window, the standard one, hit zoom 6. Zoom 6 will always take you back to the 10 by 10 window. And that's a shortcut for you because a lot of times things that we do in here are going to fit in the 10 by 10 window. This one just happened to be a little bit bigger. Zoom 6 gets you back to that 10 by 10 window. Okay, so we got standard form. Now we've done the intercept form. The last form that we're going to talk about is called vertex form. Guess what's easy to find when it's in vertex form? I bet it's the vertex. Absolutely. The vertex is right there in the problem for you if it's in vertex form. So let's look at vertex form to finish up today. Vertex form. Vertex form looks like this. F of x is equal to a, that same a that decides which direction the parabola opens. If a is positive, it's going to open up. If a is negative, it's going to open down. All of those things are the same with that a. Then you have a set of parentheses. Inside of that parentheses, you will have x minus h, and then close the parentheses and hit squared, and then plus k. That is the vertex form, okay? In vertex form, the reason they call it vertex form, this right here is the vertex, the ordered pair, HK. Notice that it's a minus sign in there, so it's the opposite when you pull it out. So if it's -3, then your x value is going to be +3. If it were +4, your x value would be -4. It's always the opposite on the H. Opposite on the H. The K value stays the same. Whatever it is on the outside, it stays the same. Okay? That gets us, not only does it get the vertex for us for free, what part of the vertex is the axis of symmetry? The X value of it, the H. We get axis of symmetry for free too. So we get two things for free on this one without having to do absolutely no work at all, which is a good thing. So when it's in vertex form, it's easy to find the vertex. It's easy to find the axis of symmetry. So let's look at an example, and we'll be able to get those two things out of the way really fast. And then I'll show you how you can get the X-intercepts pretty easy with this too. Okay, so f of x is equal to 2 parentheses x minus 3 squared plus 5. Okay. So first thing is axis of symmetry, and I'm just going to abbreviate here. And then the second thing, I'm not going to have to do any work, so I don't need to really have a lot of space there. So the vertex, I'm just going to go ahead and get that first because I recognize that that's in vertex form. If I recognize it in vertex form, I know I got the vertex super easy. Look at the value inside of the parentheses. It's x minus 3. So that's a -3. So when we pull it out, we take the opposite. So it's +3. And then whatever number is hanging out here, that's the y value. So it's a +5. So we keep it +5. So 3, 5 is the vertex. Is that vertex a maximum or minimum? Why is it a minimum? Yeah, the A in the front, the 2, is positive, so it's going to open up. So we know that's a minimum. So there's our vertex. We know it's a minimum because A was positive. Vertex was 3, 5, so our axis of symmetry, x equals 3. Automatic. 2 things for free. Super easy, no work. Just lay on top of it. Right there. Perfect. Thank you. You need a note for...
No, it's
Okay.
okay.
Now, next thing we want to find are intercepts. So let's find the X-intercepts. How do you find X-intercepts? In standard form, how did we find X-intercepts? We set it equal to 0. In intercept form, how did we find X-intercepts? Set the equation equal to what? 0. In vertex form, how do you think we find X-intercepts? Set it equal to 0. Anytime, no matter what kind of polynomial you have, we're dealing with quadratics today. When we get to bigger polynomials, we get to rational equations or rational functions. Anytime you need to find an X-intercept, set the equation equal to 0. That always works. That is a hard and fast rule that never changes in mathematics. If you want an X-intercept, set the equation equal to 0. So we're going to set this equation that's in vertex form equal to 0. 2 parentheses x minus 3 squared plus 5 is equal to 0. And then we're going to solve that. Well, this one, you can do it several different ways. One way would be to multiply the thing out completely, get it into standard form, and then do quadratic formula. That's definitely a possibility. It's a long possibility. It takes a lot more work to do that. I'm going to show you if it's in vertex form, the easiest way to solve it is square roots, if it's in vertex form. Okay? Standard form, I would almost always just go quadratic formula unless I saw the numbers and knew it factored really fast. Okay? If you recognize it, if it's a polynomial that you factored a bunch of times, like x squared plus 7x plus 12, we know that's 4 and 3. And you recognize it real quick, then factoring is great. But factoring doesn't always work. Quadratic formula works really good every time if you can do it correctly. If it's in vertex form, square roots works really well, and it's fast. And speed is something that you kind of want to start building up here in math as an Algebra 2 student, because in 2 weeks, you guys are taking ACT. You get 60 problems in 60 minutes. It's fast, okay? So being faster at things can be helpful. So I'm going to subtract 5. And when I'm solving by square roots, what am I trying to get by itself first? The squared part. The squared part here is the parentheses. That's what I'm trying to get by itself. So I'm going to divide by the 2 now. So that gets me x minus 3 squared is equal to negative 5 over 2. Then I want to undo the squared. How do I get rid of squared? Take the square roots. X minus 3 on the left side. I took the square root of a negative over here. What does that mean? It's going to have an I involved. Okay? So it's actually plus or minus, technically square root of 5 over square root of 2 times square root of 2 over square root of 2. Rationalize. That's a square root of 10 over square root of 4, which is 2. So it's I radical 10 over 2. Does that cross the x-axis if it's complex? How can I know if that crosses the x-axis? What's a short, quick way to decide if something crosses the x-axis? What do you have on your desk? On your calculator. Absolutely. We have that nice tool that can help us decide, does that cross the x-axis? I'll go ahead and tell you, because it has an I in it, it doesn't. Anytime you have a complex solution, it's not going to cross the x-axis. If there's an I, it's not going to cross it. If there's not an I, then it will. always. Okay, so this one's not going to cross the x-axis. So x-intercepts, are there any? No, there are none. Okay, so if I graph that, if I go to y equals and type in that equation, 2 parentheses x minus 3 squared and then plus 5, if I graph that, we see that parabola up here. It's not crossing the x-axis. There's no x-intercepts. Okay, that doesn't mean there won't be a y-intercept. We're going to try to find one. There is one to this, by the way. So let's find that y-intercept. How do you find y-intercept? No matter what form you're in. Set x equal to 0. F of 0. We take that, 2 parentheses 0 minus 3 squared plus 5. So that'd be 2 times 9 plus 5. Which would be 18 plus 5, which is 23. So it's 0, 23. Way up there. Makes sense that it's way up there because it was out of my screen. We didn't see it crossing the y-axis, but because it was off the screen. When you look at that graph there, way off the screen. Okay, so we get a y-intercept, we get vertex. We found out there were no x-intercepts for this one. That happens sometimes. When does that happen? Whenever I have an I and when I try to solve it. If I try to take the square root of a negative, that's when I'm going to have no x-intercepts. Okay. Now, the last thing was the table. X, Y. In the center of the table, I'm going to put my vertex 3, 5. And then I'm just going to pick some x values to the left and the right of that. So so I'd pick 2 and 1, and then 4 and 5. And I'm going to use my calculator to help me fill in the table. Okay. I'm just picking easy numbers that are next to that. If your vertex happens to be a fraction here, still pick easy numbers. I wouldn't pick other fractions to plug in because that just complicates it, right? Because you're picking the x values, you pick the ones you want to. The vertex is the only one that's decided for you already. So pick easy numbers there. So I'm going to pick in 2 and 1, 4 and 5. So on the calculator, I'm going to hit second graph to get to the table. So when I want to type those numbers in, I'm going to hit second graph to get to the table. Then I'm just going to type in the x values from that table. I had 1, 2, 3, 4, and 5. And I get the y values that go with those. And I'll just fill in my table from there. 13, 7, 7, 13. I should be able to plot those points on the graph paper and get the parabola shape out of that. That shouldn't be a big deal. Been plotting points since 6th grade. We can check our graph by looking at the graph on the calculator, right? We know what it's supposed to look like out of that, okay? So being able to plot those points. Now, again, I'm not going to ask you for all of these things on every problem at all. There may be 1 or 2 problems on the test that I may ask for all of the stuff just so that I see that you're getting a relationship between the pieces. But most of the questions are based on finding certain parts of a quadratic out of that. So the Khan Academy, that's the practice for this, is built around that idea that you're finding certain parts. You're looking at the different forms and deciding which part is the easiest to find based on the form. So some of the questions that are assigned, it'll have 3 equations written there, all for the same quadratic, but they're in different forms. And it'll say which form gets the y-intercept the easiest. So which one would get the y-intercept the easiest? Standard form, the very first one, that ax squared plus bx plus c. So you look for the one that's in the standard form. And then they'll have the same problem, and they'll say which one of these forms gets you the x-intercepts the easiest. Intercept form, it's got the name, intercept form, okay? And then which one finds you the vertex the easiest? Vertex form. So it's got to look like vertex form for that to be the answer, okay? So some of those questions ask about those things, and there's other assignments that actually ask you to find those things on the equation. So If you want to start Khan Academy today, we don't have a ton of time left today, but next day we're at school is a work day in here. So I would suggest, looking at it a little bit over the weekend and not coming in cold. Maybe watch the video again Monday morning before you come in. That would be a good idea, so that you're not coming in just completely cold on this stuff. All right.